This is day 8 of Advent of Cyber 2024. This challenge is called Shellcodes of the World Unite. Glitch, a skilled but mistrusted hacker, was prepping for a tech conference. He was eager to share his shellcode script that remotely accessed his home system. As he worked, he noticed Mayor Malware's henchmen lurking nearby. They're wasting their time. I don't have anything they'd want, Glitch chuckled. He didn't realize that hidden in his home system was something they desperately sought. A research paper he wrote on Wavell's defenses. A treasure Mayor Malware was eager to obtain. So, the learning objectives for this challenge are to grasp the fundamentals of writing shellcode, generate shellcode for reverse shells, and executing shellcode with PowerShell. So for this challenge, we need to scroll down and start the machine. Once that machine is connected, you could either RDP into it from a machine you're using that is VPN connected to TryHackMe, or you can do what I'm doing, which is going to the top and starting the attack box. So we'll start with the essential terminologies. So review some important concepts to help you better understand the upcoming content. Shellcode is an advanced topic, but knowing these foundational ideas will make the rest of the material more accessible and engaging. So shellcode is a piece of code usually used by malicious actors during the exploits like buffer overflow attacks to inject commands into a vulnerable system, often leading to executing arbitrary commands or giving attackers control over a compromised system. Shellcode is typically written in assembly language and delivered through various techniques depending on the exploited vulnerability. PowerShell, a powerful scripting language and command line shell built into Windows for task automation and configuration management. It allows users to interact with system components and is widely used by administrators for legitimate purposes. However, attackers often use PowerShell as a post-exploitation tool because of its deep access to system resources and ability to run scripts directly in memory, avoiding disk-based detection mechanisms. Windows Defender, a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks, by scanning code at runtime. Common bypass methods for evading Defender include obfuscating scripts to disguise malicious content, making it harder for the software to recognize known patterns. Another technique is a reflective injection, where malicious code is loaded directly into memory, avoiding detection by signature-based detections, and we will cover the latter on this task. The Windows API. The Windows Application Programming Interface allows programs to interact with the underlying operating system, giving them access to essential system-level functions such as memory management, file operations, and networking. It serves as a bridge between the application and the operating system, enabling efficient resource handling. The Windows API is crucial because many exploitation techniques and malware rely on it to manipulate processes, allocate memory, and execute shellcodes. Common Windows API functions frequently used by malicious attackers include virtual alloc, create thread, and wait for single object, which we'll use in this task for exploitation. Accessing Windows API through PowerShell reflection. Windows API via PowerShell reflection is an advanced technique that enables dynamic interaction with the Windows API from PowerShell. Instead of relying on precompiled binaries, PowerShell reflection allows attackers to call Windows API functions directly at runtime. This will enable them to manipulate low-level system processes, making it a primary tool for bypassing security mechanisms, interacting with the operating system, and executing code stealthily. And finally, reverse shell, a type of connection in which the target, the machine you're trying to hack, initiates a connection back to your attacking machine. In this case, your machine will be the attack box. So from your attacker machine, you are exploiting the victim, then using the victim's machine, you are connecting back to your own machine using a port that you've set up. So, generating shellcode. Let's learn how to generate a shellcode to see what it looks like. To do this, we'll use a tool called MSF Venom to get a reverse shell. So in the attack box, open the terminal and enter the command. So in the THM attack box, we are going to open up a terminal, and while that's opening up, we may as well copy this command, put it into the clipboard, and paste it in. As you can see from this command, it's using msvenom to create a shell reverse TCP, or a reverse shell that uses TCP, and it works, and it's meant to work on a Windows 64-bit machine, and you are having it connect to your attack box IP, which we need to change. So in my case, my attack box IP is 10.10.116.126, and it will be used to connect to port 1111 on this machine. So we're going to be hacking into the machine that's set up for this task. We're going to use the program that is created by this code, by this command. We're going to have that program on their machine, the hacked machine, and when we run it on their machine, it's going to connect to our machine on this host and this port. So let's enter that to run it. So when it finishes running, we should see something like this. The above command generates a piece of shellcode using MSF Venom. Here's what each part does. -P shell reverse TCP. The -P flag tells MS Venom what type of payload to create, and this part specifies that we want a reverse shell for Windows. Our host and our IP this is the IP of the attack box. It tells the reverse shell where to connect back to. LP1111. This is the port on your machine that will listen for the reverse shell connection. When the target connects back to you, it will use this port. Then -F PowerShell. This specifies the format for the output. In this case, we want the payload to be in PowerShell format, so it can be executed as a script on a Windows machine. So where's the actual shellcode? The actual shellcode in the output above is the hex encoded byte array, which starts with 0xFC, 0xe8, 0x82, and so on. The hexadecimal numbers represent the instructions set on the target machine. Computers understand binary, but hex numbers are just a more human-readable version. So instead of seeing long strings of ones and zeros, see something like 0xFC instead. We can execute this shell code by loading it into memory and then creating a thread for its execution. In this case, we'll use PowerShell to call a few Windows APIs via C# code. Below is a simple PowerShell script that will execute our shell code. So let's look at the explanation of the code. The script starts by defining a few C# classes. These classes use a DLL import attribute to load specific functions from the kernel 32 DLL, which is part of the Windows API. So virtual alloc, this function allocates memory in the processor's address space. It's commonly used in scenarios like this to prepare memory for storing and executing shellcode. Create thread, this function creates a new thread in the process. The thread will execute the shellcode that has been loaded into memory and wait for a single object. This function pauses execution until a specific thread finishes its task. In this case, it ensures that the shellcode has completed execution. These classes are then added to PowerShell using the add type command, allowing PowerShell to use these functions. So storing the shellcode in a byte array. Next, the script stores the shellcode in the $buff variable, a byte array. In the example above, shellcode placeholder is just there to show you where you would insert the actual shellcode earlier generated through MS Venom. Usually you'd replace it with the real shellcode, represented as a series of hexadecimal values. These hex values are the instructions that will be executed when the shellcode runs. Allocating memory for the shellcode. The virtual alloc function then allocates a block of memory where the shellcode will be stored. The script uses the following arguments. 0 for the memory's address, meaning that Windows will decide where to allocate the memory. Size for the size of the memory block, which is determined by the length of the shellcode. 0x3000, the allocation type, which tells Windows to reserve and commit the memory. 0x40 for memory protection. The memory is readable and executable, necessary for executing shellcode. After memory is allocated, the marshal.copy function copies the shellcode from the $buff array into the allocated address $addr, preparing it for execution, executing the shellcode and waiting for completion. Once the shellcode is stored in memory, the script calls the create thread function to execute the shellcode by creating a new thread. This thread is instructed to start execution from the memory address where the shellcode is located. The script then uses the wait for single object function, ensuring it waits for the shellcode execution to finish before continuing. This makes sure that the shellcode runs completely before the script ends its execution. So, time for some action, executing the shellcode. So on the attack box, execute the command netcat-nvlp1111. So we can do that here, nc-nvlp1111. This is opening up the port 111 for netcat, so when the hacked machine connects to us on that port, we will then have access to it on there. So on the attack box, begin by navigating to the desktop, right click on the desktop and select create document, then choose empty file. Open this new file and paste the previously provided PowerShell script code into it. Look for the part labeled shellcode placeholder and place it with the shellcode we created previously. So we'll minimize this for now. On our desktop, we will do create document and empty file. We will scroll up above to right here, and we'll just keep it named as new file, but we'll copy this, place it into here, then we will open the file, and we will paste it in here. But as I said, shellcode placeholder, where if we can find that, which is right here, I assume what it wants is for us to go back to the terminal and copy this, right here. So copy all of that, so byte, what was that called, buff, so we're able to replace the whole line with it. So paste that in. Once you've added the shellcode, navigate to the attached virtual machine, open PowerShell by clicking the PowerShell icon on the taskbar, and paste parts of the code from the document you created to the PowerShell window. So which part are we copying? It's saying to copy everything up to the shellcode. So I've got this, and we will go to here, and it's apparently still loading. Okay, now that's finally done. I want us to open up PowerShell right here, and I wanted us to paste into here, though it's very slow. Okay, it might be easy to just copy from here. Now we do it again? Nope. can't paste into this. Well, I was spending ages trying to figure out how to actually copy to this machine, and just absolutely nothing is working. So I had to look it up, and there's a solution here. So if you're like me and had trouble, can't copy and paste the code from the attack box to the attached Windows machine, the way they got around it was by creating a text file with the PowerShell and MS-Venom code on the attack box, then hosting a Python simple server by writing this command and loading it onto port 80. So if we go to our attack box, we would need a new terminal, so we need a new terminal. Whereabouts are we? If we go to desktop, where we have, well, my file is called new file, so that's there. Nope, that's not what I want. What I wanted was to copy this. So copy that, put that into here, and if we run that in this directory, I think this machine should be able to just connect to this one. So we do that, and I think in here we can do, oh right, can't copy paste, so http:// then the IP of the attack box, so 10.10.116.126, then you go to port 8000, and it should be, maybe it's new file? No, I might need to rename that file. Okay, let's save this file, exit from it, we will rename it, we'll just call it PS for PowerShell, and then we'll go to here and do PS. Actually, we're meant to go to the web browser and do this. Yes, they did it here in Internet Explorer. So paste that in, and now I've got access to it. TriAc really needs to come up with a better solution to get this working, because this is kind of rubbish. So now that we've got that set up, and we've got our code, we copy and paste to here, and we put that in. Okay, I've switched back, and it seems to have ran it all. So vertalock that, then wait for this, add wait, and now this. So then paste the line below, replacing the placeholder with a shellcode, which we did. So now we just need to copy all of this within the virtual machine, the Windows one. Now we paste that in, and then enter. Well, actually I think it automatically ran it. And then I think we paste in the remaining PowerShell. It says to do it line by line, but it seems to be working fine. So it's been running that, and I think keep getting all these connection issues. So now we'll go to the attack box, and they're saying that it should be connected now. So let's open up our terminal, not that one, this one. And as we can see, we are now within the Windows machine right here. We are as users glitch. So let's dive into the story and troubleshoot the issue in this part of the task. Glitch has realized he's no longer receiving incoming connections from his home base. Maya Malware's minion team seems to have tampered with the shellcode and updated both the IP and port, preventing Glitch from connecting. The correct IP address for Glitch is the attack box IP, and the successful connection port should be 4444. Can you help Glitch identify and update the shellcode with the correct IP and port to restore the connection and reclaim control? So it wants us to use port 4444, but you're essentially just doing the exact same thing as we already did, so we aren't going to do that. We're just going to go straight to this. Apparently do have to connect through port 444. So let's rerun the command which creates the script. So this one, okay, I misread it. So they've probably got something on the Windows machine which is checking for the connection, and then we'll create the flag. So anyway, we'll create this MS-Venom again. We are going to copy this byte code here, copy, we will reopen the text file here, and we are going to replace this bytes function variable with the new one. Save that. We then switch to the Windows machine. We're going to refresh this. We will then rerun all of these 4 lines, because I'm pretty sure these, unless I got rid of the PowerShell, which apparently I did. So we are just going to copy and paste it all, and hopefully it works. Although I just remembered I haven't set up netcat on the attack box, so I need to quickly do that. So hopefully I can do that before the Windows machine tries to connect. Otherwise I need to rerun a few commands. So go back to the terminal, and we use this one. Go back to netcat, make the port 4444. Now that this is running, let's go back to the Windows machine. Okay, well it seems like every time I switch, it removes the PowerShell that I was using, because I had that open definitely. So I guess let's put that back in. And that's running, so hopefully if we go back to here, the attack box, we will see that the connection has been made, which it has. So now we will check the desktop for the flag, and we have finally got our flag. So that is all the questions answered for this challenge. That is day 8 of Advent of Cyber 2024 completed. If you like this video, make sure to like and subscribe.